Welcome to this is actually 7.4. I used the 7.3 assignment list. It just works really well. It's just a good set of problems to solve 3x3 systems. As you can see, we have a 3x3 system, and what each of these systems of equations represent. So what this one represents, x plus y plus z equals 5, it's actually a plane in three dimensions. And as we know, when two planes intersect, we get a line. And if a third plane runs through that line, we end up with a point. So the most common solution when we have three planes in space is for there to be just a single point. It's possible we have a line. They all three share a line of intersection. It's possible there's no solution. But generally speaking, if we just randomly chose three equations like these, we would end up with a point. One way to do it would be to use this x to eliminate this x, like use this equation to eliminate this through elimination, and then we'd get a second equation with y's and z's in it. Then we can solve for y's and z's, much like we did in 7.2. And the most tasking thing of that is organization. And this Gauss-Jordan elimination takes care of just the organization that we need. And what we're going to do is we're going to set up a matrix of coefficients. With the x's, I'm looking for an x to put in the first row of a matrix that would be a 1 or a -1. And I have two choices. I want one of these two rows to go first. And I'm going to do this. I'm going to go 1x, 1y, 1z equals 5. And I don't always do this, but this is like my x column, my y column, my z column, and my equal to column over here. I won't normally put that there. And then after that, I don't care which equation goes next. I'm just going to put this equation next. So I have 1x, -2y's, 4z's, and equals -1, and 0x's, 3y's, 4z's equals -1. And now what we want to do here, and I got an analogy for this, but what we want to do here is we want to basically use this x to eliminate any x value here, and if there were an x value here, I'd use it to eliminate that. And I'm going to use, my analogy is going to be, I'm going to work right down the diagonals, but my first hired hitman is this guy right here. And I want to use this guy to whack those guys. I want this to end up being 0 and 0. Fortunately, we only have half the work to do in this first step because this is already 0. We'll show you another example after this. Excuse me. So in order for 1 to eliminate this 1, I either have to multiply the second row by -1 and add them, or the first row by -1. I'm going to multiply the first row by -1, and I indicate it this way, and then go pay a visit to that row. We won't change the hitman row, 1, 1, 1, 5, but the next row will change. So I'm going to multiply this by -1 and add it there. And I always say touch, touch. We're just going to touch these things. I'll have little pen marks all over the place. So this is -1 and 1 is 0. -1, 1 times -1, -1, and -2, -3. 1 times -1, -1, and 4 is 3. And 5 times -1 is -5, and -1, -6. In a worst case scenario, the most complicated one of these that we might have, you may have to do 80 or so little itty bitty computations. Not one of them is going to be difficult, but organizing and being precise is going to be big. Most times it's usually like 30 little computations you have to make along the way. This one's not going to be too bad. Okay, and because this is already a 0, I don't have to do anything. That row just stays the same. And then after each step, I ask myself, can I do some house cleaning? And by that, I mean, take a look at equation 2. This is just the equation, -3y plus 3z equals -6. I can divide this row either by 3 or perhaps -3. I'm going to just divide it by 3. So first row staying the same. Second row becomes 0, -1, 1, -2 when I divide it by 3. And last row I can't clean it up any without going to fractions. Now my next step, new hired hitman, as I said, I go right down the diagonals. So here's my new hired hitman right here. I need -1 to whack the values in its column. In other words, I'm eliminating the y's in my original equations. So this value, I can leave it, multiply it by 1, leave it just how it is, and go pay a visit up there. So let's see. Touch, touch. 0 and 1, -1 and 1, 1 and 1, 2, -2 and 5, 3. Hitman row doesn't change. And now I'm going to use the -1 to whack the 3. So I'm going to multiply this row by 3 to make this -3 versus 3. And go visit that. So 0 times 3 is 0, plus 0 is 0. Here's something worth noting. We will never eliminate, we will never change a 0 that we worked for. Okay, so this 0 stays as 0, not surprised. So don't reanimate your zeros. We're not going to have little zombies come back to life here. Once we've worked to eliminate a 0, we're not going to change it. Now, if this problem started off with a 0 right here, we might lose that 0, but we didn't work for it. But we've technically, by now, we've worked to create these two zeros. They won't change from 0. Okay, -3 and 3, 0. 3, 1 times 3, 3, plus 4, 7. And here I get -6 and -1, -7. At which point I'm going to see if I can do some house cleaning. I can divide this row by 7 pretty conveniently, or -7. So we get 1, 0, 2, 3, 0, -1, 1, -2, 0, 0, 1, -1. And my final hitman is right here. This hitman needs to eliminate that 2. I'm going to multiply by -2 and go pay a visit here. Let's see what happens. I get 0 and 1, 0 and 0. Don't lose the 0 we worked for. I get -2 and 2, 0. That's why we're doing it. And I get +2, touch, touch, +2 and 3, I get 5. Then, for 1 to whack that 1, I'm going to multiply this by -1 and go pay a visit. 0 and 0. Don't lose the 0 we worked for. 0 and -1. -1 and 1, 0. And +1 and -2. +1 and -2, -1. And last thing I want, for row-reduced echelon form, we want to end up looking exactly like that. And I'm going to explain why in just a moment. So I need to either multiply or divide this by -1. So 1, 0, 0, 5, 0, 1, 0, 1, and 0, 0, 1, -1. And the reason is because don't forget, this is an equation. 1x plus 0y plus 0z equals 5. This is an equation. 0x's plus 1y plus 0z, or just y, equals 1. And this is an equation. No x's, no y's, z, 1z equals -1. And this is a good time right here to go ahead and take a look at how our calculator does this for us. I'm going to go clear. Let's take a look. I want to go into matrix, which is right here. That's second matrix. And I'm going to work with matrix B, and I'm going to edit matrix B, and I'm going to have it be a 3 by 4 3 rows, 4 columns. And I'm going to put my values in here. 1, enter, 1, enter, 1, enter, 5. 1, enter, negative 2, enter, 4, enter, negative 1. 0, 3, 4, 0, 3, 4, negative 1. And I'm going to quit out of here. I'm going to go back to matrix. I'm going to go to the math, and I'm looking for row reduced echelon form, and it's easier to scroll up to it. Row reduced echelon form of, back to matrix, I'm going to select matrix B. And there we go, but you're going to have to do these, show you can do these things by hand, and we might even make an Excel project that does these things for us. Okay, 26 is a special case. I'm going to come back to 26, but I want to jump to, I was just made aware, I think I knew this, but I'd forgotten that our Algebra 2 students here have not done this before, so I don't want to jump to a special case. This is actually the first problem from your homework set. I like the fact that this is a lead coefficient of 1, so I'm not going to reorder anything. I want my first hitman to be a 1 if possible. If this was a 5, I'd just deal with it. I might change the 2 to the first row. Again, you can switch the rows. So this would be 1, 1, 1, 6, 2, negative 1, 1, 3, 3, 0, negative 1, 0. I'm going to use that guy to whack these. So I'm going to multiply by negative 2 and go pay a visit right here. Hitman row doesn't change. 1, 1, 1, 6. Now negative 2 and 2, 0. That was our purpose. Negative 2 and negative 1, negative 3. Negative 2 and 1, negative 1. Negative 12 and 3, negative 12 and 3, negative 9. Okay. And then I'm going to have 1 whack to 3, so I'm going to multiply this by negative 3 and go pay a visit down here. Negative 3 and 3, 0. Negative 3 and 0, negative 3. Negative 3 and negative 1, negative 4, negative 18 and 0, negative 18. And you could turn all those into positives if you'd like in the next step, but it really doesn't make that big of a difference. So my next step is to, I can't divide anything out in house clean, but if you like, you could make these guys all positives. You could multiply this row by negative 1 and this row by negative 1. And we may do some of that later. But my next step is to use this guy to whack that and that. Now, you may be thinking divide this row by 3, but then I got to work with fractions. And you could do that, but then I'd get, if I divide this row by 3, I'd get negative 1/3 plus 1. Then I got fractions to carry forward. I don't really want to go down that road. So instead, I'm going to multiply this row up here by 3, not send it down here, but send this row up into there. See how the notation's different? I want this to become 3, and then my hitman can go pay a visit. So let's see, careful here. Touch, touch. We get 3 and 0. We get 3 and negative 3, 0. That was our purpose. We get 3 and negative 1, 2. We get 18 and negative 9, 9. Hitman row doesn't change. 0, negative 3, negative 1, negative 9. Now I've got a choice. I can either multiply the bottom row by negative 1 and go pay a visit, or multiply the hitman row by negative 1 and go pay a visit, which I'm choosing to do. So we get 0 and 0. No zombies. 3 and negative 3. 0. 1 and negative 4. 1 and negative 4. Negative 3. And I get 9 and negative 18, 9 and negative 18, negative 9. And at this point right here, I'm going to house clean this. I'm going to divide this row by, I'm going to divide by negative 3. In fact, I'm going to divide this row in the same step by negative 1 and get all positives in there. Said we might do that later. You wouldn't have to do this one, but you definitely want to do that because we have that common divisor of 3. So 3, 0, 2, 9 divided by negative 1, 0, 3, 1, 9, divided by negative 3, 0, 0, 1, 3. And hopefully you recognize what we just learned was that 0x plus 0y plus 1z equals 3. Z is 3. My final answer is going to include a 3. Okay, now I'm going to use 1 right down the diagonal. I'm at this step to whack 2. So I'm going to multiply by negative 2 and send it up. And I get 0 and 3, 0 and 0, negative 2 and 2, negative 6 and 9. And I'm going to multiply this row by negative 1 and go pay a visit there to whack that 1. 0 and 0, 0 and 3, negative 1 and 1, negative 3 and 9, and 0, 0, 1, 3. All that's left to get in row reduced echelon form is divide 3, and I've got 1, 0, 0, 1, 0, 1, 0, 2, and 0, 0, 1, 3. X is 1, 1y is 2, and z is 3. Okay, let's go back and talk about special cases. 26. I'm going to put row 3 first because I like that 1 right there. So 1, negative 11, 4, 3. Now it doesn't really matter. I might, and you can always switch rows along the way if something convenient happens. We'll have some of those examples. 5, negative 3, 2, 3, and 2, 4, negative 1, 7. So be a really good time if you think you know what you're doing right now to just try to pause and try to continue on this. Okay. I'm going to multiply. 1 is going to whack 5. I'm going to multiply by negative 1 and send it into row 2. Hitman row does not change. 1, negative 11, 4, 3. Did I say by negative 1? That's wrong. 1 to whack 5, I need a negative 5 to go pay a, times 1 to pay a visit. Touch, touch. Negative 5 and 5, 0. All right, it's going to get ugly here before it gets better. We got some bigger numbers, but this is positive 55 and negative 3. 55 minus 3, 52. Negative 20 and 2. Negative 18. Negative 15 and 3. Negative 12. And I'm going to expand a little bit here. All right, and then I'm going to multiply by negative 2 here to whack that 2. Negative 2 and 2, 0. 22 and 4, 26. Negative 8 and negative 1, negative 9. Negative 6 and 7, 1. Negative 6 and 7, 1. Okay, let's continue on there. So my next step would be, well, can I house clean anything? Well, I can at least reduce by 2 here. Mercifully, I can get those numbers down a little bit. So I'm going to divide 2. 1, negative 11, 4, 3, 0, 26, negative 9, negative 6, and 0, 26, negative 9, 1. And now, This 26 is a lousy hitman to have. I want this 26 to eliminate that negative 11. And what I would need to do in this case is, it's going to be ugly. The least common multiple between these two is 282. It's 11 times 26. I would multiply this row by 26. I'd get a negative 282. I'm going to multiply this row by 11 and then send this up. And I'm going to do this even though really we don't have to, because something special is about to happen for us. But watch this. And we may need to work off the side, but 26 and 0. Negative 282 and 282. There's our 0. Now I'm going to work off the side. This would be 104 and negative 99. 104 and negative 99, 5. And this would be 78 minus 66, 12. Sometimes we have to go through that. Wouldn't have to here if we planned ahead. Next step is multiply negative 1 and send it down. And here's where we're going to get a special case. But first, 0, 26, negative 9, negative 6. 0 and 0. Negative 26 and 26. That's why we're doing it. Positive 9 and negative 9. Bonus 0. 6 and 1, 7. And let's take a second and interpret this. This means 0x plus 0y plus 0z equals 7. When can that happen? Never. That's the best thing that could happen for us. If this ends up 0, 0, 0, 0, that's a whole other issue that we're going to need to address. And then we have multiple solutions where maybe all three planes lie in a line. Okay, they all intersect in a line rather than a point. Okay, one more here. Let's take a look at 36. This original 40, that's the type of problem that we'll talk about in class. All right, I like this bottom row for my top row. I notice I can't reduce. I believe we might even have a special case going on right here. In fact, if you notice that, you may be able to shortcut this, but take a look here. Got some interesting values, but I'm going to just be a robot here. 1, negative 1, negative 5, negative 3. There's the third row. First row, 3, negative 2, negative 6, negative 4. Last row, negative 3, 2, 6, 1. So we're just going to robot, even though we might notice we got some interesting things going on with those two planes. We're just going to robot this one. So this guy is going to be in charge of whacking those. So I'm going to multiply by negative 3, visit there, and then I'm going to multiply it by positive 3 and visit there. As always, Hitman row does not change. Whoops, right here. Negative 3 and 3, 0. Positive 3 and negative 2, 1. 15 and negative 6, 9. 9 and negative 4, 5. And now paying a visit to the bottom row. 3 and negative 3, 0. Negative 3 and 2, negative 1. Negative 15 and 9, and 6, negative 9. And negative 9 and 1, negative 8. Nothing to house clean here. Obviously, I noticed there's some interesting stuff going on here. New Hitman wants to whack that guy and that guy. So I'm going to leave it as it is and pay a visit there and pay a visit there. That's nice. So 0 and 1, 1 and negative 1, 9 and negative 5, because the 9's not changing, 4, 5 and negative 3, 2. Hitman row doesn't change. That's bad. Put it over here underneath. And times 1 and down. 0 and 0. This was positive 1. That was positive 1, right? Yeah, that was positive 1. I think my pen just touched there. 1 and negative 1, 0. 9 and negative 9, 0. 5 and negative 8, negative 3. And again, what does that mean? 0x plus 0y plus 0z equals -3. It can't happen, no solution. Again, when we get 0, 0, 0, 0, we got some more work to do, but this is the best thing that can happen to us. It shortens things down for us, and we have no solution. 3 planes that don't have a common intersection. Okay, we'll have some special things to take a look at along the way when we go through the assignment. Number 21 is done from your assignment, so that's going to leave you with about 10 more problems or so. They're going to take some time, and good luck. Let me know what I can help you with.